MG1125, taking part in the Techfest 2015 Magneto event. I'm Atul, team captain.
Hi, I'm Karthikeya.
I'm Sagar. I'm Puneet.
We are from IIT Kanpur Electronics Club.
We have taken part in this event in the October only, and this is our first progress report. Basically, our whole board is divided into three sections: electrical, electronics, and mechanical part. The software covering part regarding the code of Arduino is quite trivial and can be made in 1 or 2 days, so it won't be covered in detail here. First, my teammate will cover the mechanical aspects of our board.
So for mechanical, we have used two systems. First of all, we have used slingshot mechanism for the throwing of the ball, and for changing the angle, we have used a motor at the downwards. And for moving the board, we have used two tires and two casters.
There are two casters on the inside, as you can see here, and two normal motors using this wheel. We have used two-wheel differential drive for driving our board. The other important mechanical aspect is that we have used a unique system to propel our board. Instead of having a single system for both catching and slingshotting, as is done in the previous teams, we have tried to use two different ones. First, we have used this flipper that will try to extend this slingshot up till where it is needed, and we have used three different kinds of rubber band that we have manufactured here at our 4i labs. These rubber bands I will show you in great detail in afterwards. These rubber bands are actually quite resistant to different pressures on this aluminum sheet, and what it basically does is to provide pressure uniformly on whole the four sides, so that we have a smooth mechanism. Also, we are trying to improve this mechanism and may come up with a new one in our future board. The second aspect is covering electrical part, which will be explained by my colleague Puneet Sharma.
Electrical, there are one motor driver and one lithium potassium battery of 12 volt, which provides the required energy for this board to be moved, and
then we have H bridges, which are of course necessary when you are trying to rotate, when you are trying to control microelectronics, when you are trying to control microelectronics using microelectronics. So we have actually 10 days of these wires. Our board is completely in the prototype phase, and so this circuit looks so bad in this shape, but we will come up with a better and neater one in our future board.
Next, I will tell you about the electronics of the board. First of all, we have used the electronic glove. Basically, it has an Arduino and an accelerometer and this TX and RX, that is RF module. So this is a 434 megahertz frequency. It transmits the data by the hand gestures. We also have flex sensors that by the movement of the fingers, we can just bend the flex sensors and get different resistance and get different values. By the movement of the hand like this and or this, we can get different rotation about X and Y axis, so that we can get different values, which are transmitted by the transmitter to the receiver, which is placed here.
We have shown quite a little bit of innovation in this part, where we have tried almost 20 different positions of accelerometer with respect to the flex sensors. With the combination of accelerometer being here in this position where we have finally rested it, with it being under the Arduino, where the actual sensors of the accelerometer were getting interfered with the electromagnetic waves that were generated in the Arduino itself. Also, these flex sensors are not the usual ones. We have tried to I wish I can show you without compromising the disintegrity of our glove. These sensors are not the usual ones where you are just using a potential divider to convert this to voltage sensing functions. These are special temperature dependent heat sensors, because if say our board is in this condition, we are using it in the climate in room temperature. So we have used these sensors that do not give different values at different temperature. Also, as you can see, we have used a genuine Arduino Uno from Italy that we have tried to solder with the GPP board here on the campus itself. We had tried to use PCBs, but they would be quite costly at this stage and will probably be present in our final board. This is the electronics concerning the glove that will be on our hand and will be completely wirelessly separated from the actual board. On the actual board, we have quite a little bit of electronics, which is quite difficult to portray in a single video, but I will try to do best. We have this Arduino Uno on our board too, that is connected to quite many sensors. First, there is this sensor called RX module. You can see this little bit chip here with 8 sides. It is actually put on this lithium potassium battery that tries to wirelessly connect with this TX module on glove. This is the way that we try to communicate between the TX and the RX module. We have tried Zigbee and SPDuino modules before, but the problem with those is that they are overkill for this problem. This is a cheap $1 electronics piece that is enough and is not used, and any use of such electronics equipment such as Zigbee will only try to complexify this problem. The second and the most important electronic piece that we are using here is actually this GPP board. What we have done here is this resistor. We have pulled down resistors using here. You can see we have pulled it down here. Well, we have not simply connected the GPP ports and the plus and minus monkey scripting type of circuiting that the people do from copying from the net. We have actually tried using different kind of resistors and tried to pull down such that the integrity of the electronics, the plus and minus voltages are not simply plus 5 and minus 0. We have used analog pins here, and this complete circuit is completely robust and will not actually diverge from what is predicted under any circumstances, under which we have tested actually. And not any circumstances would be a tall claim, under which we have tested would be completely right. Also, there will be a demonstration of this board with wirelessly communicating with our glove following this a little presentation.
Demonstration of our board which we have made for Magneto event. We have used 5 hand gestures. So this is the hand gesture used for moving the board in the forward direction.
The U sign.
Yeah.
As you can clearly see, both the wheels are rolling at the same RPM in the forward direction.
Yeah.
So our board will go straight.
Yeah. And this for the brake.
Acha, when we have the board going straight, we can either slow it down using inertia, as we can see here, or we can slow it down using our brake gesture. Now we will demonstrate the brake function, which is gestured by this. So first we will make the board go. Like you can see, the brake has been activated.